So in assignment 10, we have one router to interconnect our two subnets. The router is sitting here with this router symbol. I have blown up the router a bit to be this entire rectangle here, and the name of the router is VSIX1. So this router, we can see what's going on inside the router when we put stuff in here. We have PC1, we have PC2 that we want to interconnect, and they are on these two different subnets interconnected through the router. So in order to see routing in action, we need to generate some traffic from PC1 to PC2. What I'm going to use here is a ping from PC1 to PC2 to demonstrate that. Let me bring up a workstation here. Here we have PC1 sitting over here, PC1, and I'm going to send out a ping from PC1 here to PC2. I have a count of 2, so only 2 pings will be sent over. And there we have it, sent from PC1 to PC2. So what actually happens when we send a ping is that our PC1, in this case, will compose an IP packet that I have shown you down here. This IP packet with a destination IP and a source IP. If I bring up our ping here again, we can see that the destination address 192.168.11.2 was entered by us as a user when we issued the ping, and that is by the communication stack and the software on PC1 used to compose our IP packet here with this destination address. The source address that we have, let me take that away, that we have over here is coming from what you have set in this case, the static IP address of PC1 to. So these two IP address information are taken, as you can see here, indicated by the arrows from what you have entered in the terminal and from the PC's static IP address. So what happens when the PC is issuing the IP packet here is that PC1 will send, let me close that, send this packet over to the router in on G001 interface into the router, and the router will look at the destination IP that we have over here, the destination IP there in the entire IP packet, and the router will see that, okay, that has to go out on my GE002 interface right here onto the 192.168.11 subnet to the .2 PC2. So the router will route the packet out here, and there you have it. The router has routed from subnet 10 over to subnet 11, our IP packet here. Routing in a nutshell, only showing the IP addresses involved here in this case. The router obviously routes in both directions from 10.11 and from 11 to the 10 network. So let's take a look at a packet going in the opposite direction. I'll bring that up here. The ping reply. It's not important that it's a ping reply, but that packet will by PC2 be sent to the router because it's destined for the 192.168.10 network. So PC2 will send that up to the router. The router will look at it again and see that this is destined from the 10 network, which the router will realize I have that on my GE001 interface. That's where the 10 network is sitting, and it will send the packet out here on PC over to PC1, and then PC1 will receive that and see what it has to do with it. That was the router routing from the 11 network over to the 10 network. In order for the router to do routing, it has to be configured So it now knows where to send the packages that it is receiving. And to configure it means setting up the routing table, among other things. But I'll bring up the routing table here that we as networking engineers have to configure. Take a look at it. Here we have the routing table for VSIX1 in this case. What we put in here is fundamentally two pieces of information. Destination subnet, in this case, the 10/24 subnet, and we tell what interface is this subnet hanging out of, or where should this subnet be, on what interface should this subnet be defined. Likewise, we have the next row here, which is the 192.168.11.0/24 subnet, and that is on GE002, which we have there. So GE001 is designated for or assigned to subnet 10, and subnet 11 is assigned to GE002. So this is fundamentally all the configuration you have to do in the router, telling where are the subnets located, on what interfaces do I want to have these subnets. So let's look at the details again here, or let's look at the details. Now we have the routing table in the game. PC1 will look at the destination address of the package it has to send out, and it will realize that, okay, this is not on the subnet that I'm on. So I will send that over to the router. So PC1 sends this up to the router, and here we have our IP packet that we want routed inside the router. What the router will do is it will be looking at the destination IP address. It will then make a lookup in its routing table and see, okay, is this a match? Is this the best match I can find to this destination IP? No, it's probably not. I'll look at the next IP address, or in my routing destination column here, and it will realize, okay, the algorithm in the router will realize, okay, this is the best match I have for this destination. Okay, what interface do I have to ship this packet, IP packet out on? And that is GE002. So what the router will do is it will send the packet now out, as we saw before, also out on GE002, which it has just realized is the correct route for this IP packet. So to recap, PC1 sends up to the router, and the router looks at the destination IP, realizes where that subnet is, where that networking device, receiving device hopefully is sitting, and it will send that over, in this case, to PC2. If we look again at the echo ping reply here, it's not important that it's an echo reply. It could be any traffic that we were looking at. What we're interested in here are the IP addresses, in this case, the destination IP. PC2 will look at the communication stack in PC2, will look at the IP address and realize, okay, this IP packet is not destined for my own subnet here that I'm on. It's not for another networking device on this subnet. So PC1 will send that packet here. It will send that over to the router, and that is what we do here. It is going over to the router. The router again will look at the destination IP address and say it's 192.168.10.2, and it will start looking up in its destination routing table here, or forwarding table, and it will look at, in this case, row 1 and say, bingo, compared to all the other entries, we only have one other entry, compared to the other entries, this is the best match for this destination IP. Where do I have to send it to? I have to send that out on GE001. So the packet will be sent by the router out on that interface GE001, and that is exactly where we have PC1 sitting, which is the destination, has the correct destination IP here for this IP packet. PC1 will say, thank you, Mr. Router. I will take a look at what it is. Oh, luckily it's a ping reply. So pings are actually going through the router as we expected. So there you have it. This is, I would say, routing in a nutshell in its most simple form. 2 subnets, 2 interfaces on the router, 1 routing table in the router, and the router is doing its lookups there to see where the various packages, IP packages coming in, where they should go to. Obviously, these IP packages, they are packed into Ethernet frames with preamble headers and MAC addresses also, but we will look at that in another video.